inscribed angles of circles. Inscribed. What is an inscribed angle? It's an angle whose vertex is on a circle. So here's the angle's vertex, it's on a circle, and whose sides contain chords of circles. So if you're inscribed, you're inside, this angle is inside the circle. Okay? We call this an intersecting arc. It is formed by the rays of the angle. That's an intersected arc. There's really kind of two of them. I guess you could think about the arc going around the other way. When you create one of these guys, inscribed angle, intersected arc. So the measure of an inscribed angle theorem. Ready for your theorem? The measure of an inscribed angle, so here's an inscribed angle, is 1/2 the measure of the intersected arc. Here's your intersected arc. So if your measure of your intersected arc was 100 degrees, what would your angle be? 50. Exactly, that's how it works. So if I have an example here, circle P, I want to find the measure of angle T. So I have an inscribed angle. I look and see if I can find the intersected arc. No, I'm sure it is. Here it is. So what's the measure of angle T? 24 degrees. So you just take half of the arc. Now if you're given the arc, here's measure QT, or I want to find measure QT. I say, gee, can I find an inscribed angle? Let me look in here. Oops, here's one. So what's the measure of arc QT? Yep, 100. Easy peasy, right? Half the arc to get the angle, or double the angle to get the arc. Questions on that? Fairly straightforward. Oh, this is a good one. If two inscribed angles of a circle intersect the same arc, then the angles are congruent. I think this one is kind of obvious a little bit. Let's say that two angles intersect the same arc. So if this arc was 100 degrees, what would be the measure of angle B? What is that? 50. Now angle C is intersecting the same arc, so what is he going to be? Or she? Also going to be 50. So if you see two angles and they kind of touch in this way, like they have the same arc there, congruent. So let's see, find the measure of angle WXV. WXV, so I want this one. Well, whatever this arc is, I don't really care what this arc is, but just for laughs, what is the measure of this arc? What is it? 144. And I don't really need to use that. Now, because that's 144, I can see that this one's going to be half of that. But if I can recognize, you know what? Half of the same is going to be the same. So I can just see that right away without having to do that extra step. You can if you want. It's not wrong to do it. But it's just you can save yourself a step. More theorems. Oh, no. A right triangle is inscribed in a circle if and only if bidirectional. The hypotenuse is the diameter of the circle. Look at all that bullshit I've been here. So we have a right triangle. If the hypotenuse, the side opposite the 90, is the diameter, then any inscribed angle is 90. If and only if. So if you start with a diameter, you can get 90. If you start with 90, you know this is diameter. A quadrilateral can be inscribed in a circle if and only if, once again, bidirectional. Its opposite angles are supplementary. So the measure of D and the measure of F. Measure of angle D plus the measure of angle F equal 180, supplementary. The measure of angle E plus the measure of angle G, opposite angles, are supplementary. Now, if you're given a quadrilateral and this is not true, you cannot inscribe it in a circle. So it works both ways. If you have opposite angle supplementary, you can make a circle around it. If you are in a circle and you draw one, then the angles will be supplementary. So it works both ways. Questions on either of these two things? Again, none of them are all that tough. It's just a matter of remembering all of them. So let's look at a few examples here. I'm on the bottom here of page 1. Are these our guys? based on those theorems, I don't think you need me. Go ahead and give these a shot. Turn these guys on. Hopefully only 56 here. But how'd we do, or how did I do? And let me know where the questions are. Please ask if you haven't. Oh, they're still working? Give me a couple more seconds. Yeah, you're telling me we're good. No questions. We used all our little theorems. Okay, fine. Let's move on. Another theorem. How many theorems are there? I don't know. If a tangent and a chord, so here's my tangent, here's my chord, and they're intersecting at a point on the circle, then the measure of each angle's form is 1/2 the measure of the intersected arc. Now, it may be a little hard to see the intersected arc here, so you kind of see angle 1 here. So what arc do I have formed here? This red arc. So the measure of that is 1/2 the measure of the arc. So angle 1. So if this was 100 degrees, what would the measure of angle 1 be? 50 degrees. Okay? But then you're doubling it. The other side, right, there really are two of these intersected arcs here. If this one's 100, what would the measure of ACB be? 260, right? 360 minus 100. So then what would the measure of angle 2 be? Just take that. So none of these are like rocket science, but they're there. So let's see, find the measure of angle 1. Well, if this whole thing is 220, what am I looking at here? What's the measure of this guy? Really? What is it? Yeah, we're not awake. We thought it was going to be a snow day. We didn't want to. Anybody listen to that weather report that said we were getting like 5 to 8 inches? That was on weather.com. It's like, oh, awesome. Or we might get nothing. It's one or the other. All right. That's my stretch. 0 to 5 inches. Thank you. All right, EFG. I'm finding an arc now. So be careful. Are you finding the arc? You're finding the angle. So EFG is this arc. So what's the angle that goes with this arc? The 135. So what's this going to be? What is it? 270 degrees. Again, not rocket science, but you have to know the theorems. And you have to be able to find the different angles. And sometimes these are a little tricky. Which angles am I talking about? Sometimes they'll do and say, here, I'm giving you all this. Find EG arc. How would I find the measure of EG? That arc. How would I do that? Yes, right? So what's this angle going to be? 45, which makes this thing 90. So it's usually not going to be quite this straightforward. You're going to chase it around a little bit. If you know your theorems, okay, sure. So here are your tries on these. Were these kind of in the middle-ish of page 2? Go ahead and give these a try. Yes? Oh, I see. Like if you're looking at this one, you kind of follow where the rays are going. Now, where's the arc in between? Should be here. If they give this angle, you look at these rays and say, gee, where's the arc that goes with it? That would be this one. If it helps to extend this a little bit, you can do that. It might be easier to see it. Okay, so give it a try. Rematch? Did we get the same thing? Questions? Yes. Okay. Yes, you could. Because this is 90 and this is 90, what can I say about it? The line. It's the diameter. So kind of looking at it, it's kind of putting together different things that we know. If it's 180 degrees, that's a semicircle. That only happens with diameters. So these are kind of things that, these are like little separate exercises, but you can sometimes get little complicated pictures. And so kind of recognizing things, there's a little bit of an art, and it takes practice. So each theorem by itself, not so bad. When you put them all together, you really got to think about it. All right, this one of my favorites. I got a bunch of favorites, but I like this one. So when you have circles, you can have intersecting lines, and there's different ways that our lines can intersect. So you can have a circle with two intersecting lines that meet right on the circle. You can have intersecting lines that meet inside the circle, and you could have intersecting lines that meet outside the circle. And depending on these situations, we can actually find out different measures. For instance, I know this relationship, this arc and this angle. What's the relationship between this arc and this angle? Because you just looked at this one. Who shall I call on? Katie, what is the relationship?
The angle is 1/2 the measure of the arc.
Yes, the angle is 1/2 the measure of the arc. So we're going to look at different other kinds of relationships. So let's see what we got here. Angles inside the circle here. So if you're intersecting inside the circle, if two chords intersect inside a circle, then the measure of each angle is 1/2 the sum of the intersecting arcs. What? All right. If this arc is 50, because that's an intersected arc, here's another intersected arc. Let's say it's 100. And I want to find angle 1 or this angle, right? They're congruent because they're vertical. This plus this, and then divide by 2. It's basically the average of those arcs. So if you wanted to find the measure of angle 1, add the two arcs, then divide by 2. 150 over 2, I get 75, and this would be 75. Angle 2 is the measure of this plus this over 2. And again, you're going to have a matching angle 2 on this side. You can also find one of these and notice that they're a linear pair and subtract from 180. And then go backwards. Like, what is the measure of the arc going to be? Well, what is angle 2 given that this is 75? Yeah? What is it? 100. And let's say they gave you, this one is, I don't know, let's make that also be 100. And I want to find that measure. So you can kind of put them together. X plus 100 over 2 would be 105. Multiply both sides by 2. 210. And then X would be, subtract 100, 110. And hopefully all these add up to 360 if you get it right. Yeah, it does. Nice when it works. So again, relatively simple theorem, but kind of working with it. So find the missing angles here. How would I find angle 2? Let's see here. I'm not even giving all the answers. Let's see, somebody else can play too. Sam, how am I going to find this angle? Yes? This theorem will always work. If one of these is diameter, yes, it'll still work. But how would I find angle 2? So twice, 115. Oh, you just put that in a calculator. So 115 plus 97. What is that? What's angle 1? How'd you get that? Right? You supplementary, so 180 minus 106. What else we got here? Find the missing arcs. So I'm missing this arc. So let's see. How am I going to set this guy up? I'm going to call this missing arc X. I'm going to call that Y. Yeah, how do I set it up? Over. Right. So X plus 66 equals 140. And then whatever 140 minus 66 is, I should know that in my head. I don't. 74. Okay, now I need to find this measure of arc 2. I've got a couple of choices here. What are 2 ways to find the measure of arc 2? 2 ways. Way 1. Somebody give me way 1. Let's see. How would I find it, Maria? Okay. Okay, so this one would be 110, right? So this plus this divided by 2 is that. So what I call that y plus 126 over 2 would be 110. And y plus 126 would be 220. So y would be 220 minus 220 minus 120. 220 minus 126. 94? What did you guys get? What's another way? That was way 1. What was way 2 to find that? You know, when is the angle half the arc? Now, if I had one here, this angle is half the arc. Has to be inscribed in the circle. These are not inscribed in the circle, are they? So I can't use that one. But there is another way to find it. What's the other way?
Check or add on the other angles so that people know it's 60.
Yes. 74? Right. I know they all add up. So you know this. You never know what's going to happen. You're taking a test. Sometimes one goes away, one comes the other way. Use whichever one comes to you. That's fine. You should get the same thing. I hope you do. Okay. We've got, I think, this guy. All right. If you're outside the circle, right? Remember, there were 2 possibilities. You're on the circle. That's the one you talked about. If you're on the circle, it's half of this. If you are inside the circle, you average the arcs outside. Now, if your meeting, your intersection is outside the circle like this, it's similar to this guy. It's similar to the one we used for this, which is this plus this over 2. But now, it's a subtraction. It's going to be this red arc minus this blue arc divided by 2 gives you angle 1. Subtracting, right? Difference. If you have this situation, 2 tangents. This red arc minus the blue arc, divide by 2, you get angle 2. Here are 2 secants. Red minus blue, divide by 2, gives you angle 3. So find the missing angle. 92 minus 43 over 2 will give you that angle 1, and that's why we have this guy. 92 minus 43, divide by 2, and I get 24.5 degrees. Sometimes they're not even numbers. Okay, that's 2 secants. Here I have 2 tangents, and this one's a little tricky. I need this piece minus this piece, divide by 2, and I'm going to get 45. What do I know about that other piece? Okay, what am I going to do here? Because I need to know this measurement. Right? This minus this over 2 is that. Any ideas? I want ideas. You were working this. I know you got ideas. What are you thinking about, Emily? I know you're working it.
I think, sure. 360 minus that.
Oh, let's back it up. If this is x, what's the measure of this?
360 minus that.
Yes. So this is 360 minus x, and that's x. I think this is where you're going. Take the outer one, minus that inner one, divide by 2, and that's what you set up. Yep. What do you think? Smart, right? Smart girl. All right, so let's see what we get. Multiply both sides by 2, as well as we need to kind of fix that a little bit. So 360 minus 2x equals 90. And I'm going to move that guy here and move this one here. So I'm getting 270 equals 2x. So divide by 2, looks like x is, I want to say 135. Is that right? Okay? Maybe? Oh, here we are. 135. We are on page 3, right? Okay. All right. And then this is, you've got a tangent and a secant. So again, you look for those intersected arcs. This one's a little more straightforward. It's just 138. My eyes are horrible. Is that the right number? over 2. Alright, let's see what we get. 148 minus 66. Divided by 2. 36. Okay. And that's all she wrote. Questions? Alright, we're ready for some new tries. Okay, for the fast people, tell you what I got. You can tell me if I'm right or if I'm wrong. Or I'm right and you're wrong. I guess that would be the other possibility. Or we're both right or we're both wrong. We got all kinds of possibilities. What do you think? Do we agree? Okay. We agree? Anybody disagree? If we disagree, I don't know who's right and who's wrong. Anybody not finished? Anybody not know what to do? Anybody want me to do one of them? Guys, they're so charming today. Look at you guys. Yes, sir? C. This guy? Okay, the measure of angle 1. So I'm outside the circle, so it's this thing minus this thing over 2. So 220 minus 140 over 2. That's what our answer is, 220 minus 140. Divide by 2. Wait, you get to divide by 2?